Hello, my name is Herman Weiner. I'm a volunteer at the National Museum and a member of the museum's conservation team. Over the last few years, we have been refurbishing the astronomical telescope which stands behind me. The telescope was manufactured by Thomas Grubb in Dublin in 1883 and purchased by William John MacDonald in 1885, who added it to his observatory at Port Macquarie in New South Wales. Using this telescope, I will talk you through an observing session. During the afternoon before the observing night, MacDonald would have checked the weather to make sure that the sky would be clear. Once he had decided the weather would mostly be fine, MacDonald would have prepared a program for the night. I'm going to demonstrate how he would have observed and measured double stars. Towards the end of twilight, MacDonald would have gone to his observatory and opened the shutter in the dome and prepared the telescope. First, he would have removed the protective cap at the objective end of the telescope tube. After removing the protective cap, MacDonald would have to turn his attention to the telescope drive. The telescope is fitted with a geared drive powered by a falling weight inside the pedestal. This weight has to be wound up at the beginning of observations. The last gear reduction in the drive is a screw and geared sector, which has to be rewound to the starting point. It permits the telescope to be driven for about 2 hours, after which the sector has to be rewound again. The telescope speed is regulated by a governor, which MacDonald would have to set to a predetermined value. Now that MacDonald had started the drive, he would check the telescope illumination system. Observations are done in the dark. Hence, some illumination is required to read the telescope setting circles. The light source is a small bulb at the end of the declination axis. Using a number of mirrors, it provides light to the declination circle and the position angle scale, and it allows the observer to view cross wires in the micrometer. A separate system operates for the polar axis circle, which I also switch on now. After MacDonald had switched on the illumination system, he would set the telescope to the first object he wanted to view. In our case, this is a double star. To set the telescope, he needed 3 values: the object's coordinates of right ascension and declination obtained from his catalogue and his notes, and the local sidereal time at Port Macquarie. This telescope is equipped with a separate sidereal time circle on the polar axis. He would then set the telescope to the star's right ascension by moving it around the polar axis and clamping it to the drive. After setting the right ascension, MacDonald would now set the declination. He would unclamp the telescope tube and rotate it to the value from his notes. MacDonald would then look through the declination circle reading telescope to read the setting. The telescope is equipped with slow motion controls on both axes. MacDonald would use these to make some fine corrections to the telescope position. Having satisfied himself that the telescope had been set correctly, MacDonald would look through the finder telescope to locate the object. No doubt he would need to make some other small setting corrections using the slow motion controls to center the star in the field. Having made these adjustments, he would look through the main telescope and again center the object, if necessary, in the field of view. Now that the telescope was ready, MacDonald could observe the double star. For this observation, he required a measuring micrometer. Two measurements have to be made. The first one is the inclination of the line connecting the two stars with respect to the celestial equator. For this, the whole eyepiece assembly is rotated, and the resulting angle read on the position angle scale. The second measurement is to measure the separation of the two stars. For this, the micrometer is fitted with two thin wires, the separation of which can be adjusted with a screw and a scale which can be read. He would then have noted both values in his diary. If the weather remained clear, MacDonald would have probably made a number of other observations. Once he had finished his night's work, MacDonald would put the telescope back into the rest position. To do this, he would stop the drive. Then he would unclamp the telescope in right ascension and declination. He would then replace the protective cap at the end of the telescope tube so that moisture would not condense on the objective lenses. MacDonald would then move the telescope back into its rest position. I'm going to put it back into the position as you see it in the gallery.